In this section, we will be dealing with Matplotlib module again. And here we will be discussing polar plots and pie chart or pie plot. And we will be using the pie plot option to draw the polar plots as well as pie plot in Python. Again, I will be using this online platform to execute the programs because multiple tab option is not working with the Google Meet. So in order to show you the results as well as program at the same time, I will be using this particular online method. And you can also run your own Python programs in this particular online platform, and you can verify whether it is working or not. Okay, so let's start with the topic. First one is the polar plots. The polar plot representation displays the variation of magnitude against phase angle on polar coordinate system with change in omega from 0 to infinity. So in polar coordinate, if you consider polar coordinate, points are represented as r and theta. That is nothing but the magnitude part as well as the phase angle. And the any mathematical function that we represent by using the Cartesian coordinate system, by using the xyz coordinates, that can be converted, or that can also be represented in polar coordinate system with r and theta. And as you can see, in polar coordinate system, we have only two parameters, r and theta. We can represent the position by using this r and theta. Any points we can represent by using this r and theta. And since we are having this angle here, we can use this particular polar coordinate system or this kind of representation, especially in case of navigations. And a modified version of the same is used in aircraft for navigation purpose. So this is simply a coordinate system, polar coordinate system you can consider, and which is having this r and theta. When you're considering polar plots, we'll be having r and theta as your coordinate system, as the axis. That is nothing but the angle as well as the magnitude part. So by using these two, we can represent or we can have different kinds of plots in that is called as polar plots. And in Python, the pyplot module in Matplotlib gives the function polar that is used to draw the polar plots in Python. So I will be just going through the theory part now, and later we will be discussing uh, the program section. Okay, so here we are having this first section, which is the polar plots that we have just covered, the introduction of that. And we will be considering drawing circle by using the matplotlib dot pyplot dot polar function. We are using this polar function in that pyplot to draw the polar plot. Okay, so this particular function we will be using to draw the polar plots, and we will be considering it as matplotlib.pyplot.polar because pyplot is inside this matplotlib, and in that pyplot we are having this polar function. Okay, so first we'll take as an example, we'll take a circle, drawing circle in that as the polar plot that is in polar coordinates. And again, we will be drawing this ellipse also by using r and theta, by using coordinates r and theta. That is nothing but the polar plot of that particular ellipse. Okay, so there also we will use the same function to draw the polar plot. So that's all about polar plot theory part. And as you know, this circle will be having some particular equation when you consider that in the polar coordinate system. A circle is consist of, as you know, that is consist of a large number of points which are at the same distance from the central point. And we'll be having a particular equation for r, that is the distance from the center for the circle. as well as for ellipse, we'll be having such kind of a equation for r with the theta. Okay, so we'll be using that particular equation to draw the circle as well as ellipse in polar as a polar plot. Okay, so we'll be considering these two examples, and for ellipse case we also consider the semi-major axis, semi-minor axis, all those parameters. Okay, then we will go to the pie chart, and pie chart also you are familiar with these things. So a pie chart is a type of graph which records data in a circular manner, which is called as a pie. And that is further divided into different sectors to represent the data in that particular uh, sect. Okay, which means that you will be having, you for example, if you are considering number of fruits and the different fruits you have to consider, like apple, banana, like that. And if you are considering count of those fruits, so each of these will be different in different classes. So all those classes will be represented by sectors in that pie plot. Okay, or you can call it as a words in that pie plot, and each of those words, if you consider, and that will be representing a particular class with some particular data. Okay, and we can have different kind of operations in this pie chart by using this pie plot option. And these pie charts or a pie diagram helps in representing or interpreting data more clearly. And this particular pie chart is commonly used to get a comparative study, or to do a comparative study, and we will get a comparative result from these pie charts. Okay, and we will be covering this creation of pie charts, how we can create pie chart by using this uh, particular matplotlib.pyplot option. And also we will consider, and in that case we will be using a particular function which is called as pi in pyplot to generate or to create that pie charts. And then we will consider how we can color this pie chart, how we can change the colors of this pie chart, different verges of that pie chart. Okay, that we will be considering, and for that we will be using the colors function to give color to all those verges. And then we'll be considering labeling the verges. Okay, so in that case also we'll use the label function available in pyplot for that. And we'll go to this start angle setting. Start angle is nothing but when we consider the pie chart, it will be starting from one particular angle. Okay, for example, it is starting from 0, then it will be at that x-axis, and it will be starting from there in the anti-clockwise direction. Okay, so we will explain those things in while doing the programming, so you will be able to understand that more clearly. Okay, so we can change that starting angle by using this particular setting. So that we can set by using the start angle function in pyplot. As also we'll consider the explode option, and in some cases we need to have some kind of representation, like the verges are separated from each other, or at least one verge is separated from the remaining, and these kind of representations will be useful to give a clear idea of the data that we are dealing with. Okay, and then we'll consider the shadow effect, and also we'll consider the legend in case of pie chart. Okay, so we'll look more into these things while doing the program. So I will just erase this. So this I have used to show you the theoretical part of this thing. Anyway, so we will first start with the polar plots, how we can just create or generate a polar plots. For that, we have this kind of this particular program. So this one I have already uh, written. So you just go through these steps. So this is first step is import numpy as np. This is required because we need this pi value in this particular program. So we need this numpy module because this pi value is stored in this numpy module. So first I have to import numpy as np here. Then I have this matplotlib option, that is import matplotlib.pyplot as plt. So I am importing this pyplot from matplotlib and which is imported as plt. So I can use this as my name now for this pyplot. So plt dot, which means that pyplot dot axis, that is axis representing that plot, that particular plot, axis of projection. So here I will be using polar as my projection, which means that I am plotting that particular polar diagram or polar graph. Okay. So here I am setting polar, which means that I have to plot I have to represent whatever I am giving, that is in polar plot. Okay. So projection is polar. Then I am having this r equal to 4. This r is nothing but my magnitude or the distance from the center. Or we can consider, in the case when you're considering that as a in the case of circle, we can consider it as a radius. Okay, so I'm just plotting, this is an example for circle. So this is my radius of that circle, that is r. And then we have this radians, so that you can change this into any name, that is not a problem. You can give a or b or something like that also, no problem with that. So I have given here a short form for this radians, that is the angle that we will be considering as the second coordinate in this polar plots, r comma theta, that I have said earlier. So this radians will be np dot arrange. So for getting this arrange function also, we need the numpy module, so that we have imported this numpy here. So np dot arrange. So this we are getting some particular set of values with by using this arrange function. So it is starting from 0 and ending at 2 pi. Okay, 0 to 2 pi with step size of 0.01. So this much of values will be stored in this radians. So that will be considered as the values for this radians. And from that radians, I am taking values, all those values as a for loop for I in radians. Okay. So for I in radians, so first value of that radians will be taken as first I. Okay. And that once that is taken, all the values of that particular radians that is taken, then we have this plotting of that particular circle by using this polar option or polar function in pyplot. So I'm just plotting polar plot. I'm considering polar plot, and I am having this r value here, that is my radius, and this I is my angles, different angles I that is defined in this radians. So my first angle is 0, then it is increasing by 0.01 and up to 2 pi. Okay, so that is what I'm doing here. And then I'm plotting by using this plt.polar function. And I have specified here what is my angle, what is my radius. And I also have this r dot here, that is for the color as well as style. So here I will be using R as my color, which is red, and dot is representing each and every points. So that is my marker. Okay. And then we have this plt dot show, which is to show or to display that particular graph or plot. So that's all about this program part. So each time it will be considering this I value. These I values are stored in this particular, that is in this radians. That is these radians values are taken with the function range from 0 to pi with step size 0.01. Okay, so now if I run this program, I will get a circle as a polar plot. And some error is there. Oh, I think this dot is okay. So I should get a circle in that polar coordinate system with the theta and r, and they are all those points will be at a distance r, that is at 4. Okay, so you can see from this circle, the circle is red in color and which is having points which are just dots. Okay, and you can see the distance of that particular circle is 4. That is, I mean, radius of that circle is 4. So this is from center. You can consider this circle is having a radius of 4. Okay, and since we considered here 0, 0, 1, 0.001, sorry, 0.01, the dots are very close to each other. So I can just reduce this one into 0.1 to show that they are just dots. So step size I have reduced so that the number of points in that radiance that will be less in this time. Okay, now you can see that it's a circle which is formed by using these red dots. Okay, so all those red dots are representing different angles, plus they are at a distance of this r, this radius r, that is 4. Okay, so this is how we can draw the circle as a polar plot in polar plot or polar coordinate system. So this is the polar plot, and you can see angles which is starting from 0 at that x-axis. It is 0 degree, and it is increasing in anti-clockwise direction. You can see that here. So it is starting from 0 here, and it is increasing in the anti-clockwise direction like this. Okay. So this is how we can have a circle in these polar coordinates, and so this is just r and theta. We have only two coordinates here, r and theta, to draw this circle. Now, how we can draw the ellipse? That also we'll consider as a second example. So I have a code for that also. So just copy that here. I will remove. So I have done this in ideally module. Ideally, so that's why these things are coming. Anyway, I will place all those things. Okay, so I have given some notes here. This import math, I have used math module here because I am using the square root function that is in this math module, and also I think okay, that's enough. Okay, that's all. And then I have here setting projection as polar for axis, that is to generate the polar plot. And then we have the semi major axis here as a equal to 5. When you are considering ellipse, we will be having semi major axis as well as semi minor axis. So semi major axis I have put a equal to 5, and for semi minor axis I have taken it as 2, b equal to 2. And then I have these radiance values, different radiance as rad, and I have given that values to this I, that is I in rad. For that values, this for loop will be running, and while running, it will be generating different points for this I, and this will be given to this as an angle to this sine as well as cos. So this is equation for ellipse for the in polar coordinates are equal to a into b, that is semi minor axis, semi major axis into semi minor axis, a into b divided by square root of this math dot sqrt is for square root of uh, a sine square plus b cos, a sine theta square plus b cos theta square. Okay, that is the equation for the ellipse. Okay, so this a sine theta whole square, it is. So we have to consider here. You can see this is a sine theta whole square and b cos theta whole square, and that is taken inside that square root. So that is the equation for this ellipse. And then we have for all those points, for all this r, we have to plot this polar plot we have to consider. So PLT dot polar, and I is the angle. So I we have considered, first we have to consider as 0, then 0, comma, r we have to consider. So for r we will be generating from this equation for all those I values. Okay, so for all those I values, we will be having different r here. In this case, for ellipse, that r will be changing, but in case of the circle, that r will be constant. So each time we have to consider this r, and then we have used again this red color dot for plotting, and we have used this PLT dot show to display that particular plot. So I will run this one. Let me see what it will come. So there is some error. I think this math. Oh, this one is not good. Let me see whether it's working now. Yeah. So you can see that we have the ellipse in this polar coordinate system. So this is a polar plot, okay, of this ellipse. So in this case, you can see the point we are having this starting point at this 0. Okay, this is my 0 degree. That is my first value of I, and for that we'll be calculating what is my r. So this is the r for that particular I, that is 0 for that 0 degree. This is the r. But when you consider 45 degree here, so my r is reduced to this much, around 2.5. Okay, so initially my r was around 5 almost. Okay, 5, but here when you consider at 45 degree, my r is around 2.5. Okay, so depending on the angle, my r is going to change. That is obvious from this equation. It depends on the angle. Okay, and in this way we can generate the ellipse as a polar plot. And we can change this if you want to get the clear picture, then you can change this step size into some other value. Let's consider it as a point 1. In this case also, let me see. So that step size I have changed, which means that I'm reducing the number of I values. Okay, so the total number of points will be reduced, so that we can see that each of those points clearly. Okay, you can see that now in this figure, and if you can also change the dot into star if you want to use some different marker. You can check different markers, different colors, different semi-major, minor axis, all those things that you can check. If you change this one to let's say 4, then again it will change. Okay, now you can see the maximum of your radius or r value will be the semi-major axis value, that is the 4. That is 4. So you can see that is 4, and then it is decreasing. This is your minor value. Okay, that is nothing but 2. Okay. Okay, so that's all about the ellipse and the polar plots. Now we will go to the pie plot or pie chart, and I will just copy the pie chart here. So first I will show how we can draw the pie plot simply. pie chart assembly. So this is the code for that. So this is just a pie diagram. I will just run this first. Oh, this I have to remove these sections. So in this code, you can see I have imported this matplotlib.pyplot as PLT, and then I have imported numpy also. Why I imported numpy? Because I have to use this array option. So when you are using array, then you have to use this numpy. So importing numpy in this step, okay, to get that array, and then I have used this a as my array, and that is data for each wedge in that pie chart. Okay, so this data or the pie chart wedges, when you consider, each of those wedges will be associated with some particular data. Some maybe it is some mark, some number or something. So in that case, each of those wedges will be associated with some particular number, some value, and that value that we have to give in a list or in as an array, as you can see from here, and each of them will be that should be in that particular order that we want. So all those things that we have to set here. So this is this 20, 50, 31, 10 representing that data for each of those wedges in that particular pie chart. And then we have to draw the pie plot. For that, we have to use this pie option. So I am using this data, which is stored in that particular array A. So that I am giving that array name A here, pie of A. That means I have to draw pie chart of this particular array with these values. Okay, so plt.py, that I have to use this pie function to draw the pie chart, and then finally I have to display the chart by using plt.show. So I will just run it down. Yes. So now you can see this is our pie plot or pie chart. And you can see that it is starting from this axis, as we discussed for the polar plot. It is starting from this x-axis, positive x-axis. If you consider this as your origin, and this can be considered as your positive x-axis, and it is starting from here in this point, and this one is 20, representing 20, whatever it is representing 20, and this one is representing 50. This one is representing 31, and this one is representing 10. So this is the representation of each of the wedges with the values that we have provided in this array. Okay, and it is starting from here. So this is 20, and it is going in the anti-clockwise direction. So it is starting here, and it is going in the anti-clockwise direction. Okay, and now we will look much more deeper into this and how we can edit these things, how we can improve this pie chart with more options, so that we will discuss with this particular program. I will be just clearing this side. Okay, so now you can see here I have I have imported my matplotlib, and from that I have imported the pyplot also, and then we have this import numpy as np, and I'm using this array option again, same array I'm using. So this is the data for each wedges, and then we have this subjects equal to a list of values or characters that you can see from here. So this is just a list. You can see here, this is a list, and all the data inside the list, you can see this is English, Maths, Physics, Chemistry, and each of these one will be representing a particular wedge in the pie diagram. Okay, so this list is used as labels for each of those wedge in that pie diagram. Okay, so this will be using as the labels, and then I will be having this x width, and this is used to I will just explain that a little later. So this is the displacement for each wedge from the center. Okay, so you will be, you can see that while after running the program. So here we are also giving colors for each of those wedges. So color specification for each wedge that we have to give here, and each of these options or these functions, subjects, the X width, these colors, all those things, which means that this is for labeling, this is for that width or separation from the center when you are having that exploding option. This is for colors, or this we have to include in this particular plotting option. Okay, so plt.py, then I have used a is my array here, as you can see. So I am using that array to plot my pie diagram, and I am using labels function here to label each of those words that I am using, that will be in my pie diagram. So the labels will be equal to subjects. What are the subjects? Subjects I have given as a list for different strings are there, and that will be considered as my labels. Okay, so labels I have considered, which is equal to subjects. Subjects is that subjects is nothing but a list of values. So that values will be considered as my labels. Okay, and then I have given here stat angle. Stat angle specifies where you have to start your pie diagram. So by default, it will be starting from that x-axis, as I said. So here you can see it is starting from here. So that is my 0 degree, or we can consider it as an x-axis. So this is my 0 degree. So it is starting from 0 degree, and it is going in this anti-clockwise direction. So that you can change. You can start from this position, from the 90 degree, and you can go in the anti-clockwise direction also. So you can you can specify that particular start angle or starting angle by using this start angle function. So here I have given it as 90. So here this is 0, okay, but here I have given it as 90 so that you can see the change. And then we have another option, explode. Explode option is used to have a separation of a particular wedge from the whole part. Okay, so suppose if you want to get this second part of your total pie diagram separated from this whole part, then you have to give this particular explode option. And here I am using explode equal to x width. So this explode equal to, after this equal to, I have to specify what is the separation distance for each of the words that I have to get separated from the whole part. So I am considering x width as 0 as a list. You can see here, this also we have to provide it as a list, and that list is having value 0.200. Okay, so this is representing my first wedge is not separated, that is 0, that is separation distance is 0, and second wedge is 0.2 separated from the center by a distance of 0.2, and here third wedge is 0, which means that it is not separated, and fourth wedge also it is 0. And this list is I have given this list name as here in for this explode, so that it will take directly these values as the distance or the separation from the center for each of wedges. And this shadow, that is another function that you can give to get a better picture, or to have a attraction, to have some kind of attraction towards that pie diagram. So it is improving that diagram, basically this type. Okay, so that you can specify here whether you want some shadow to your in your pie diagram for each of the swatches. And then we have this color. We will be using colors. Okay, this is another function to specify the color of words. So I'm using here colors as a list. You can see here CLRS as my list, and that I have given for this colors function, so that it will directly take different colors from this list. So first one is B, that is blue. Second one is R, that is red. Then I'm having G green and K, which is for black. Okay, so all those additional features are added with this plt.py. So that plt.py is basically for drawing the pie diagram. And for the first case, we have considered only this A, that is my array. And we have drawn the pie diagram. And now we are using this labels function to label each of the words. And then we have start angle to specify the angle where we have to start the pie diagram or the wedge. And then we have used the explode to have some separation of wedge from the center or from the whole part of the pie diagram. And then we have used shadow to have a better look. And then we have this colors function to give color to particular wedge. So there we will be specifying the colors. Otherwise, it will generate automatically by some default colors. And then we also have legends here. So we have used plt.legend option. So it will directly take these labels, okay, with these colors as the legend to represent the legends. Okay, so we have to give plt.legend to show that legend in the diagram. And then finally, we have plt.show to display the chart or the plot. So now I will run this program. Let me see whether it will work. I think there is nothing error here. Okay, now you can see each of these options. So actually you can work out this particular program one by one, like first you give label, then you give start angle, you change start angle and all those things. All those things you can perform. I have just given here all the functions in a single line, okay? So now you can see as compared to the previous pie diagram, this is same data, but we have changed these styles, different styles. Okay. So now you can see the different labels here for each of these wedges. Each of these wedges, we have this math for this wedge, physics for this wedge, chemistry for this wedge. So we are labeling each of the wedge, and we have the legend here. You can see English, maths, physics, chemistry legend with that particular color. And we are also having this shadow option, shadow in each of these wedge. You can see that. And also color that we specified. The first one is with the blue color. So this one is the first one. And you can see the starting angle, which is now at 90. So it is starting from here. And this is the first one, that is it blue color. And this is the second one, that is red color, then green, then blue, then black. And also you can see my second wedge, which is separated by some distance from the center, from the whole part. Okay, so this is just an example. If you want to get the first one also separated from that whole part, then I can give you here some 0.1. And also let me change the angle. Okay, anyway, first I will show you this. So here I have given the first one also separated from the whole part by 0.1 distance from the center. So now you can see that the first one that is English, that particular wedge also separated from the whole part. And if you want to change this starting angle, for example, I can give that is 0. So it will be starting from 0 degree. That is from that x-axis position. By default, it will be starting from there, and you can specify the starting angle by using this start angle function. Okay, now you can see it is starting from 0 degree from here. So, okay, so this is how we can draw different, or how we can draw the pie plot in, how we can draw pie diagram. I'm confused with this. I'm just while expressing it, I'm repeatedly saying it as pie plot. Anyway, so this is just pie diagram or pie chart. Okay. So this is how we can draw the pie chart or pie plot by using Matplotlib option, and we have discussed some of the important options that is available in this pie plot for plotting pie diagram, and you can look for more options, more functions in these sections. Okay, so that's all about it, and we will look into some other plots, some mathematical functions, plotting mathematical functions like sine, cos, some special functions like Bessel function or Legendre functions, all those things in the next class. Okay.